Explain a video script, Understanding the Multiplexer. Hello everyone, and welcome to this quick explainer on a fundamental component in digital electronics, the multiplexer. My name is Felix Kweijo Junior, and my index number is 24254000419. I offer cybersecurity and in level 100. Today, we're going to demystify what a multiplexer is, how it works, and what outputs it provides. At its core, a multiplexer, often abbreviated as MUX, is a data selector. Think of it like a digital switch that allows you to choose one of several input signals and route it to a single output line. In the image you're seeing, we have a 4-to-1 multiplexer. This means it can select one out of 4 input lines. Notice the multiple input lines labeled I0, I1, I2, and I3. These are the data inputs, the signals that we want to potentially send to our output. But how does it know which one to pick? That's where the select lines come in, labeled S0 and S1. These select lines act as the controller for our switch. With 2 select lines, we have 2 less than sup greater than 2 less than, sup greater than, or 4 possible combinations, allowing us to select one of the 4 input lines. Let's break down its behavior. Inside the multiplexer, a combination of logic gates, specifically AND gates, NOT gates, inverters, and an OR gate, work together. Each input line, I0 through I3, is connected to its own AND gate. The select lines, S0 and S1, along with their inverted versions, created by the NOT gates, are connected to these AND gates in such a way that only one AND gate can be enabled at any given time. When a specific combination of S0 and S1 is applied, only one of these AND gates will have all its inputs high, allowing its corresponding data input, I0, I1, I2, or I3, to pass through. All the outputs of these AND gates then feed into a single OR gate. Since only one AND gate is active, the OR gate simply passes that selected input signal directly to the final output. So, what are the outputs we get? It's straightforward. For example, if S1 is 0, and S0 is 0, the multiplexer selects the I0 input. If S1 is 1, and S0 is 1, then I3 is selected, and its signal is passed to the output. To put it simply, imagine a train station with 4 different tracks coming in. I0, I1, I2, I3, but only one track leading out. The signals S0 and S1 are like the switch operator, determining which incoming track is connected to the outgoing track. Only one train can pass through at a time, and the multiplexer ensures the right one is chosen. Multiplexers are essential in computer architecture and digital systems. They are used for data routing, parallel to serial conversion, and simplifying complex circuits by reducing the number of wires needed. And that's the multiplexer. A powerful component that allows us to efficiently manage and select data in digital systems. I hope this explanation has made it clearer. Thank you for watching.